Yes?
For non 1, I had trouble with 48.
All right.
Which one?
The one about the CDs, section 9.1, number 48. So the first step is to set up the equations, but they basically gave you the equations, is that right?
Yeah.
It's like 1, 1, 1, so x plus y plus z equals 37, whatever you can call them, or a plus b plus c equals 37 if you want to use a, b, and c. Well, actually, part A, they tell you use x, y, and z. So where did you run into trouble?
It was like in solving it. I don't know if I did it right, because at one point I just got 0 equals 0 for something.
All right, so give me your equations that you got. One equation is x plus y plus z equals 37.
3x plus...
Yeah, 3 of these plus 2 of these plus 1 of these is 69.
And then x plus y
Yes.
4z equals 82.
82.
So I think it's just in solving it.
All right, this is the first part of 48. This is 48 part A. They pretty much gave it to you. They gave the coefficients in the little box. So now you got to solve, and there's some, real quick, while I got this up here, some problems look like that. They start with some missing letters already. Let that be good. Right? So in a discussion, that means they've already killed a letter for you. So you have to kill one more time between something else. And your goal is already like one step done. Right? So don't freak out. If some letters are missing already, why is that good? Because I'm trying to make them go away. I'm trying to make my unknowns go away so I can get one unknown figured out, and then I can work backwards. This one's got everybody. Oh, shit. So part B says solve this thing. So what letter do you want to kill off?
I would say the X's.
Sure, it almost doesn't matter. They all have equal things to do, basically. Right? There's none of them are different signs, which makes sense. You're not going to say I have negative 2 CDs. This is a physical problem. So how do I kill what's the most immediate way to kill the X's?
You could do 1 and 3 and then times 1 by a negative.
I like it. So negative 1 times 1 and 3. So this would be negative x minus, down there. Negative x minus y minus z. Negative 37. And then 3 I leave alone. So here we get our first little weirdness. Is everybody with me so far?
Mm-hmm.
What's up? So why did I multiply 1 by negative? I have to multiply
that. Yeah.
so that it would kill this. So I just wrote negative 1 and I wrote 3.
I was just lost with the signs right there, but I see how they changed because you did the negative.
And now I add these together. What weird thing happens when I add these together? What weird but really nice thing? 2 variables die. If I want to kill variables, then I get 2 of them dead at once. 1 shot, 2 zombies down. Right? I'm excited about the walking. Bam, bam. And I get what? 3.
Thank you.
3z equals 45. So z is 15. Now, anytime something happens that isn't always something that happens, it gets a little weird. This is nice. I know, bless you, I know z already. I had to do barely any work, but I know what z is. But now you're like, bless you, now you're like, what do I do? This is not what normally happens. What do I do? Well, now I know what z is. So everywhere I see a z, I can replace it with 15. And then I have 3 equations with only x and y in it, right? So let's see. If I plug a 15 in, what do I get here? I know z is 15. So at x plus y plus 15, right? Subtract 15, so I get x plus y equals 22. Is that cool? Put a 15 in for z. Why? Because I know z is 15. So then subtract 15, bam. What do I get here? 3x plus 2y. Replace z with what? 15. Why? Because it is freaking 15. Subtract 15 and I get 54. Now the third one's going to be a little anticlimactic. I get x plus y plus 4 times 15 is 60. Subtract 60 and I get x plus y is 22. I already know that. So what? All right, big deal. It's true, isn't it? X plus y equals 22. I already knew that. So I can't really use that. It's not new information. Why is this good? Because now I only have 2. And you can do substitution, you can do elimination, whatever you want to do there. So almost anything that happens that is not what we went through as the textbook, this is what happens most of the time. If something different happens, most of the time that's good. That means more canceled, or there's less variables to begin with. That's all good. That's all good. The minute you know a letter, you can plug it back in. And now I can solve those two to figure out what x and y are. Yes?
So when you are doing that, right here, are you supposed to do both equations, or could I have just did the x plus y equals 22 and then solve for y?
Can you really solve for y?
No,
No.
the x is still there.
So you need another equation with it, because there are two things in that equation I don't know. Between the two of these, I could kill the y's or the x's and figure out the other one.
Okay.
So anytime if I have one variable I don't know, I only need one equation.
Okay.
If I have two variables I don't know, I need 2, 3, 3, 4, 4, 4.
Okay.
Yes, ma'am?
On the number, you did number 3, x plus y.
That's what that becomes, right?
On number 3 becomes that?
Yes. Because 4 times 15 is 60. Subtract 60, and you get 22.
And it's the same thing on that one.
Yeah, so it's nothing new. It's still true. It's a true statement,
Okay.
but it's not going to help me because I've already got it here, right?
Okay.
That's the only reason I crossed it out. It's still there, but I've already got it written down. Why write it down twice? Now, what can I do between these two? How can I solve for something between these
Do
two?
elimination or substitution.
Multiply this by -2. I love it. So you can kill the y's. Multiply by -3 so you can kill the x's. Solve for y, substitution method if you want to. It doesn't matter. You can solve this little equations right here. We already know what z is. I now can figure out what x and y is, and I'm done. Maybe. So the nice thing with these problems is if something weird happens, like 2 variables go away or some variables are missing, let that be nice. That's good. Almost anything that's different is good. Believe it or not. Yes?
I have a question on 27.
Okay. What's up? Bless you, bless you, bless you.
So they all have, well, 2 and 3 are missing variables, so I can't figure out how to add them together.
So you see how, for example, the second one has only y and z in it? So let me give you this, and then I'll show you the ultimate shortcut with this specific problem. The second one only has y and z in it. So this is number 27, right?
Yeah.
Okay. So 27 looks like this. Right? No, 5. And then y plus z equals 6. And then x plus z equals 3. So if you want to force it to be like, so let me show you something, and then I'll ask you guys if you see anything better than what I'm about to say, because there's better things you could do, but this will work. You see how the second one is missing an x? So remember, what do I do? What do I do in general? Like if it looks like this, what do I start? I try to kill a letter, and then I kill it again. Well, x is already dead here. Can I kill it again?
No.
Can I kill it again? Yes.
You can kill it here, but here it is not available.
Here, I can kill x again, right? I can multiply this by -1 and kill it, and then I get an equation with y and z in it. So I'm already one step closer to the textbook method, right? So if I took 1 and multiplied it by -1, I can add these together to try to get an equation with y and z. Now what happens to the z's here? This problem's got a lot of weirdness going on. Right? But do you understand what my motivation is for doing this? If there was an x here, what would be the first thing you would do? Kill the x once, and then kill it again. That's already dead once. I just got to kill it one more time. So that's what I'm doing now, is I'm trying to kill x one more time.
If those were all positive x's, let's say 1, 2, and 3 had an x in there, could you kill it once using a negative x, -1 on there?
And you can kill it again using another -1. Right? So between 1 and 2, if there was an x here, I could multiply 2 by negative and add it to this. But I can also multiply 3 by negative and add it to this. I can kill it twice.
Okay.
Yeah, I can always kill a variable twice if it's there. Here, don't let this be a problem. Let this be nice. They've already killed this x. Sweet. I can conserve some ammo. Sorry. Again, this problem, more weirdness happens, right? Now, if this wasn't like this, and I get a y and a z, I can use this and this, y and z, and I can kill the y or the z. But here, look, the z's already died. So what do I get now?
You get y.
Negative y equals negative 2. So y is 2. Where can I go immediately with this information?
Y plus z.
Plug it in here to figure out what z
Equation
is.
two.
It wants to know y and z. I can get x by plugging it into here, for example. Right? Now let me show you something else. And very often as a student, you just don't know what you're allowed to do. Right? The more you know that you can do, the more tools you have to try. So here's something kind of neat about this specific. There's two specific things I'm going to show you. Let me show you this one because it's more generally true. I'll show you this little shortcut for this specific kind of problem because it's more true in general. And then there's another little weirdness with this one. I don't know if you guys are with me.
This is a shortcut you're showing us for the same problem.
Just because of the way the problem is, there's several shortcuts, right? Was that missing a y? Or did I just...
No, you added a y on number 1 on the very bottom.
Oh yeah, there was no y there. Alright. Watch this. This is kind of cool. Doesn't this one say... Now, again, this is just a tool, an option that I can use. Anytime I want to. Do I ever have to use it? No, you never have to use this option, ever. But, notice how I can say... Doesn't this one say that y is 6 minus z? Right? Subtract the z. Right? Doesn't it say that? Don't freak out. That's all. If y plus z is 6, isn't y equals 6 minus z? Subtract the z. And doesn't this one say x equals 3 minus z?
Plug those in for x.
And I can plug that in here and that in here, and I've only got z's.
That's what I meant.
Oh, I'm sorry.
Yeah.
I
I was
talked
like,
right
can
over
you
you.
do that? Yeah.
You totally can do that. So
Okay.
that's beautiful. Can you always do what I just did? No, it's just because of what was missing here that allowed me to do that. I can write each y and x in terms of z. So now I can rewrite the first one as what? X is 3 minus z. Y is 6 minus z. Z is z. And now I can solve for z. That only works on this kind of problem because of the way it's kind of set up. So if you don't see it, who gives a shit? There's another way to do it. You can just do it the textbook method. And even that kind of leads somewhere weird, but not weird. It leads to good weird. Right? Yes?
You need to have the 2 lines at least missing one of the variables.
Yeah, exactly.
So not just one line missing a variable, both of them have.
Exactly.
Okay.
Right, now here's and is everybody with me? So now you can get what z is. And once you get what z is, you can get what x is. And once you get what z is, you can get what y is. That's beautiful. Right? I don't know if you guys can see that. Alright, now here's a third weirdness. That's not as... That one happens more often. Here's something else that's kind of nifty. What's the second statement say? What's the second statement say? It tells me that y plus z is 6. So any time I see y plus z, I can replace it with 6. So doesn't it say x plus 6 equals 5? So now x equals negative 1. Do you see that? So do you understand what I'm saying? So I don't have to just replace x with a number. If I know y plus z is something, anytime I see y plus z, I can replace it with that thing. That's what I'm saying here, right? Yes?
Okay, so let me ask something else. Since they're not terms where they're separated with parentheses, going across there, you can mix them up, match them, x plus this, whatever, right? So
Totally.
If you're saying y plus x plus that, it still has a, you know what I mean? So
Sure. But look at this. Okay, so x plus z is 3, right?
Okay.
And doesn't it say x plus z?
Uh-huh.
So I can say this is x plus z is 3 plus y is 5, and I can solve for y.
That's what I was asking.
I like it.
Okay.
If you didn't understand what I just said, you never have to do what I just said, ever. But it's really good to know that you are totally allowed to do this. If I know that x plus y plus z is 5, and I see x plus y plus z somewhere in my problem, I can replace it with 5. That kicks ass. Now, if there was a 2 here, could I do what I just did? Hell no, I don't know what 2y plus z is. Right? I know what y plus z is. I don't know what the hell 2y plus z. But it's because it was exactly y plus z, and I know what y plus z is. I can replace it. I can substitute. So you don't just have to substitute for a single letter. You can substitute for any expression. If I know 4x minus y is 20, If I see 4x minus y somewhere, I can replace it with 20, because that's what the hell it is. So it's a much more broader idea than you realize. And maybe now you kind of realize it. It's a really good thing to realize. All right. Maybe. So all this, there are two different kind of things that came out, but you can always revert back to the textbook method, pretty much. Some weirdness happens that makes the textbook method actually the hardest method, but you can always do it that way, right? Okay, in case you don't want to, like, screw the other methods, just give me one method. All right. All right, so anything else from homework? Yes?
10.2 number 104.
Oh yeah, I like it. Kepler's laws. Some physics for you. Blah, 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 blah. Yeah, so the planets, well, now this makes sense. The further a planet is from the sun, it should take it longer to get around the Earth, right? Yep. Because you gotta go a lot longer distance. And even though we don't call Pluto a planet anymore, which I think is a grave injustice,
It's a planet.
it still, yeah, exactly. It still follows the same rule. Poor little Pluto. It's like, screw you guys. So they give me this formula. The time it takes is related to the distance in this way. The time it takes is the square root of the cube of the distance from the sun. So you cube how far you are away from the sun, take the square root of that, and that's related to the time it takes your planet to get around the sun. Right? Whatever planet you call home. The planet Neptune is 30 times farther from the sun than Earth. So D is 30, because D is the D equals 1 is the Earth's distance. We do that with a lot of, there's this stuff called astronomical units, which is the distance that the Earth is from the sun, and then we say like a planet is 9 of those because it's 9 times as far as. So Neptune is 30 times. So for Neptune, D is 30. And then it just says, how many years would it take for Neptune to orbit? Well, all you got to do is, so part A is easy, right? Hopefully. You just take 30 and you plug it in, because I know the distance is 30. So square root of 30 cubed. Oh, yes. Right?
This is, so 10 what?
10, 2. Number 102. 104. Now part B says, write this formula with rational exponents. So how do we write the square root of d cubed? What's the power? What's the power going to be? What's the root? So I want to write it as a rational exponent. So what's the root? What's the root? No, what's the root?
2.
Is 3 the root? No, what's the root? 2. Understood to be a 2. Where do roots go? On the bottom. What's the power? Where's the powers go? They're strong.
Okay, I thought they wanted like the answer from A to B.
Oh, no. That would be crazy.
That's where I got.
A is going to give you a number.
Yeah.
Yeah, they want this expression written as a rational power. Yeah.
So when it doesn't have it written up there like as a square root, it's just always implied as a square is 2, no matter what. Is that right?
Exactly. And we know this to be a 2.
Right.
Yeah. Like it. Because again, first roots don't exist. Right. First root of 8 is 8. How many 8s does it take to make 8? 1 8. Alright, so 8. Yeah, so it's no good. Okay, anything else from homework?
Going back to chapter 9.1, number 30, I'm getting like a lot of fractions with my answers, so I don't know if I'm doing that correctly.
Number 30?
Yeah, like I got 24 over 11, negative 2, and 27 over 11. That just doesn't seem
Oops,
right.
negative 2 is good. The other one's not quite. So y equals negative 2 is right for number 30.
Mm-hmm.
So y equals negative 2 is right. The other ones, it should come out to be whole integers in this case. Some of the problems come out with fractional answers. But most of them come out to be whole numbers or integers. Right? That one happens to have all integer answers. So something went wrong with your x and your z.
Well, I
So I'm
wouldn't
cool with your-
understand how to plug it in then.
Well, it depends on how you figured out what y is, since that's the only one that's right. Let me think.
Because I times the 5x by 2, and then the 5x and the negative 10x.
Oh, there you go. So the x and z canceled. I like it. So it's sort of like the one we did earlier. Now that you know that y is negative 2, you can rewrite. This is number 30 in 9.1. Now that you know that y is negative 2, you can rewrite like the first equation would be 5x minus 15 times negative 2 plus z equals 22. Right? And you can do it with the second one, and then that's all you need, really. You just need two equations with x and z in them, because then you can kill the x or the z and go from there. So I can add this, so I can, well, this will be plus 30, I can subtract it over. The second one, negative 10x plus 12 times negative 2 plus, minus 2z equals negative 8. Right?
Yeah.
So now you can move that over, and now between the two of these you can kill, well, let's see, that's not going to be any good, because that's what you used. Let me make sure you guys understand. If I kill the x's, that's going to also kill the z's, so it's going to end up giving me no answers. So I need the third guy, 4x minus twice y, but y is negative 2, minus 3z equals 9. Alright, so let's see what we get. Watch. So is everybody kind of cool with this? The very first step on number 30, you should get y equals negative 2. You should get that pretty quickly. And then it's a question of where the hell to go from there. Well, now what do I get for the first equation? I get 5x plus z. This is 30. Subtract 30, I get negative 8. Right? The second equation, I get negative 10x minus 2z equals, this is negative 24, so you add 24, you get 16. I don't know if anybody sees those are the same thing. Does anybody realize those are the same equation? If you multiply this by negative 2, don't you get this? So it's sort of like earlier when they had x plus y equals 22, and then another one said x plus y equals 22. Just cross one of them off. I don't need them both. They both say the damn same thing. So I need the third one. What's the third one say now? 4x, what's this? Plus 4, so subtract 4. So I get 4x minus 3z equals 5. So between these two, I can kill, for example, I can kill the z pretty easily, right?
Yeah.
So when two variables die and you get something earlier than you expected, that's good. Plug it in everywhere. And then you see which ones you can use to kill the other variables. Yeah.
Okay, so going back to where you said 1 and 2, you crossed out 2. You said 1 and 2 are the same.
Yes.
You multiply negative 2 on top. So since you would have to still multiply negative 2 on top with the number 1, wouldn't you have crossed off the first one since number 2 is already done? I don't understand why you crossed off the second one.
No, I don't have to multiply this by negative 2, because now what am I going to multiply to kill the z's? I'm going to multiply by 3.
No, forget about number 3 on there. You would just have 1 and 2 up there. And so you had said... So
If I did multiply this by negative 2, it would be the same as this.
Right, so why did you not cross off?
Because I want it in lowest terms, so it's easier to make it match with the other dude. It's easier to make these match than these match, right?
You could have crossed off the first one if you...
Totally, but then I would have
Okay.
it would have been worse. And it doesn't matter, it would still come out right. Your numbers would just be a little bigger in the middle. Not a big deal. But I want it kind of like in lowest terms, like an equation in lowest terms. Do you still understand what that means? Do you see? Does everybody understand that these two are the same equation? Does everybody see that? It's the same thing as saying 1/2 is the same thing as negative 3 over negative 6. Those are the same, right? Which one's in lowest terms? The one with the smaller numbers. That's in lower terms. I'm going to probably try to use that one, because then it will be easier to make like denominators in a way, right? Yeah. Yes, sir.
So you always plug it into the original equation, right? Whenever you get a variable.
Well, normally I wouldn't plug my variable back into these 3 original equations, because then I only know one number. But I got this one like immediately. And I'm like, oh shit, that doesn't normally happen. So the only place I can plug it back in is the 3 that I have to begin with. And then I get 3 equations with 2 unknowns One of them happens to be the same as the other one, so screw that one. Between these two, I can kill x or kill z.
And then you can plug that one into.
And I can plug that one into one of these and get the other variable. Right. So I can solve for x, because I can kill z. Once I know what x is, I can plug it into either one of these to get what z is.
Okay, so into that equation. Then.
Yes. Cool. I like it. So that's what I mean by if anything weird happens, I got this too quick. I got it like bam immediately. Oh shit, what the hell? It's nice, but what the hell do I do? Well, you use it. You got information. Use it. And when you plug it in, you get 3 equations with x and z, but one of them is the same. Now between these two, it's beautiful. That's back from last year. Stay with me. All right, how we go? Or last semester, or whenever the hell it was you took your math course. All right, so what's most important is to understand the basic process of how to do a normal problem like this. I assigned a few problems where there were weird things that happened because that can happen. Normally, when a weird thing happens, it's good. It actually propels you. You're further ahead than normal. Right? You don't normally get information early. Once you do, use it. Immediately use it. Yeah. All right. Anything else from homework? Yes.
We have the freedom to kill anyone, of course, right? X, Y, Z, anyone which is suitable to kill.
Yes.
And we have the freedom to multiply an example by 2, by 5, to...
Totally. Yep. Totally. You can multiply any equation in the universe by any number you want to except 0.
Yeah. Of course, yeah.
For any reason.
Yeah.
I like it.
To keep it easy, to be flexible with the others.
Totally. I like it. Can't read you guys for shit. Like I always say, don't ever play poker with any of my students, you know.
Wait, so
And I'll be
then,
like,
so then the answer would be 1, -2, and then 1/3.
I don't know. I haven't got that far. You shouldn't get any fractions for this one. Well, let's finish this one out.
I keep getting fractions.
I don't know why.
I plugged in y, and I plugged in
And you got
x.
these, right? And you
Yeah.
solve for x? Okay, so how did you solve for x? You took the first one, you did what?
I added, so it'd be 9x.
Well, if you add them, you don't kill the z's. You want to let it to die.
Okay, so what I did is I times, hold on. I times the 5x plus z equals -8/3.
Good, so the these will die, right?
Yeah.
So we see that? Well, 3, because they're already opposite signs. So it'll be 15x plus 3z equals -24. The most common mistake people forget is this poor other side. You got to do both sides of an equation or else you're totally illegal, right? The second one I leave alone. If you're erasing, so I think we figured it out.
So then the 3z cancels out, 15x and the 4x become 19x. 24 take away 5 is 19, -19. Divide by 9,
19.
19 I mean, and you get -1.
Good, yeah. You know x is -1. You know y is -2. Well, actually here you know x is -1. Plug it into either one of these to figure out what z is.
Oh, maybe because
I'll plug it in there.
-1.
So when you plug those back in, they go back into one of the.
Either one, it doesn't matter. Either one. They all have to give you the same answer because they all have to agree with the point they're at.
And it goes back into the one you figured over there, not the original one, correct?
It could go into the original ones because you do know x and y, but you already used y information, so it's silly. I just need to go back to one of these two.
Okay.
Yeah. I mean, again, you could use this one, but why would you? It's the same as this one. Lowest terms again, right?
Oh, okay, I see what I did wrong. I forgot to put the negative in front of the 1.
Ruh-roh. Okay. That's all it takes. That's all it takes. So I understand that this could get frustrating sometimes because all you need to do is put 1 instead of -1. And then everything else has no chance. Right? Because they all relate to each other. So the minute one of them's wrong, everything else is going to be wrong. That's why you should thank your lucky stars. You got a teacher that actually grades your work. No Scantron for me. If this teacher wants a Scantron to teach you math, 2 things. Don't take them, and they're not a math teacher. I don't know what they are. Right? I don't know if I told you that yet. Don't ask me if you need a Scantron, because I'm a math teacher. You do not need a Scantron for math. right? So I give you partial credit. So you make a little tiny mistake somewhere and everything gets thrown to hell, I'm going to take off just a little bit of credit. If you show me you understand the process, right? Okay. That's why you shouldn't erase all your work and just leave blank. That's horrible. Don't do that. Then I can't give you anything. Do something. You're like, this is not working. I don't know. I don't. Just keep going. Show me you understand the process. Okay. All right. Let's get back into it. So last time we finished 10.2. We looked at 10.3. Let me do a little review of 10.3, and then I want to let you guys do that handout from yesterday. I've got some more copies if you need it. Then we're going to talk about a few more sections of chapter 10, and then I got some group work, and then it'll probably be time to go. We'll see. All right? We'll see what happens. Oh, and by the way, there's a quiz tomorrow. You're funny. Like I'm not going to tell you. Quiz tomorrow. You'll find out what it's on. No. Section 9.1 and 10.2. So I have one problem with 3 variables, and then maybe a couple problems with the radicals from section 10.2. Rational exponents, stuff like that, right? Okay. So, one thing about 10.3, let me come back at it, because we talked about breaking radicals apart, but I want to make sure you understand that you can put them back together. What do I mean by that? So, for example, what is the square root of 5 times the square root of 7? What's your gut tell you that should be?
Square root of 35?
Yes, and your gut's right. Yay! Right, so if you were thinking that, you're fine. As long as the root is the same. That's exactly what we've been doing. What's no root on 5 times no root on 7? What is that? No root on 35. So what's square root of 5 times square root of 7? Square root of 35. Thank the gods. So what's the cube root of 5 times the cube root of 7? Cube root of 35. Kick ass. Alright, let me stop there for a second. You guys with me so far?
This is 9.2.
This is 10.3. Yeah. Remember, we only did the one section out of 9. And just real quick, I want to show you why this is true. So give me, you know me. Why is this true? It kind of like matches with what we would hope would happen, but we get suspicious when that happens. Like math doesn't do what I hope would happen. Cube root of x times the cube root of y. Do me a favor. How do you rewrite the cube root of x in a different form? X to the
3 over
minus 3.
1 over 3.
1/3. Right. What's a cube root do to things? Cuts it in thirds, so it's 1/3 power. So cube root of x is also known as x to the 1/3. What's the cube root of y?
is y and 1/3.
Now watch this. You ready? I can rewrite this as xy to the 1/3. Because wouldn't that 1/3 power distribute to both anyway? So I'm kind of like undistributing. I'm sort of factoring that power out. And how do I write this as a radical? It is the third root of
xy.
So what happened effectively, I just multiplied those together. So see this step right there, this step would not work if these were not the same, would it? If those were not the same, this step would not work. So that's why if they have the same root, I can just go ahead and multiply the insides under that root.
Is that a 3 at the root on the very last thing you wrote?
Yes, that poor little 3
Sorry.
kind of melted into the radical. Alright, so let that be nice. Let the hell thank God. That's why we're able to do stuff like this, what we focused on the other day. How would I do the cube root of 24? Do you know what the cube root of 24 is? If you do, you're better than me. But I can at least simplify that. I don't know what the hell cube root of 20. I know what the cube root of 27 is. What's the cube root of 27? 3. So what's the cube root of 24 roughly? 2.9 or something, right? Because it's really close to 20. It's just below. But what is it exactly? I don't know. That would be a decimal that would go forever. If you can't simplify a radical, it's a decimal that never stops.
So we can say, like, in example, Not 4 by 4 and
Yeah, you can break it apart.
yeah.
So you can either do method 1, which is to break it up as cube root of, what number can I take the cube root of that's a part of 24?
3.
What can I take the cube root of? What kind of number? 8. 8's in there, 8 times 3. What's the cube root of 8? 2. What's the cube root of 3? I don't know. Third base. All right. So what method 2 would say, just take 24, 6 times 4, for example, 2 times 3 times 2 times 2, right? That's the other method if you want to do this way. What's a cube root looking for? Groups of 3. So I can take 1, 2 out to represent those 3 2's. And what's left inside? The poor little dude that's by himself. So either way you do it, you get the same answer. Right? Both of those methods are on that handout from yesterday. You're like, I'm just like slide in the second? I don't know what you're saying. Alright. Okay. So watch this. Let's see. So we're going to do the handout in a second that deals with that. But let me just do one last thing here. Before I do that. So what about this here? Square root of 6 times the square root of 10. I like it. I like it. That's a good next step. Because they both have square roots, right? Yeah, and now you can break it down. So you could have a multi-step problem, right? Whenever you combine two like radicals like this, the last step you do, what do you do with fractions? What's the last thing you do with a fraction problem? See if your answer can be reduced. So that's why I like calling this reducing the radical. It isn't really, but who gives a shit? It's nice because it's the last thing you do with fractions. It's the last thing you do with radicals. Can you reduce the radical? Of course you can. How can you rewrite 60? What number that goes into 60 that's square rootable?
4 times 15.
4, yeah, 4 times.
Some number, 15.
Square root of 4 is?
2 times.
Square root of 15 is? I don't know. How could you see that from the beginning? What's 6 got? How did I make this problem? How did I know it's going to work? 6 got what in it?
2 and 3.
And a 10's got. So you see, I knew I had 2 2's to be in there. I knew it was going to work because it was going to collect. The square root needs 2 of something. I made sure it was going to have 2 of something in there. And what's left? 3 times 5 is 15. It gets left in because there's only one of each all. Table for 1.
So your answer just is 2 times 4.
2 radical 15, yeah. And of course, that's method 1. If you wanted to do this the other way, you would just take 60, 6 times 10, 2 times 3 times 2 times 5. You see 2 2's, so 2 comes out, and the 3 and the 5 are still inside.
And you said yesterday you don't recommend that one because it has a chance for more errors?
Yes. What I always get when somebody does this is I get like 15 rad 2 for some reason. People put the wrong numbers in the wrong place. How can something... You never take something out of a radical. What you're doing is you are doing the radical of it. Square root of 4 is 2. I didn't take a 2 out. The square root of 4 is 2. So that's what people think wrong. You can't take something out of a radical. You can't. But you can take the radical of something and have it become something else. And that's when I get weird things like this.
But I mean,
Things are in the wrong place.
Say, I mean, the most common number is 2 right there. So
I know, that's the right way to look at it. That's the right way to look at it. But I get this so often from people that do it this way. I'm like, I kind of recommend this way because you can see exactly why it's 2, because the square root of 4 is 2. This is more like, well, the square root needs 2 things, so I'm going to put a 2 there because there's 2 2's. It's a little less easy to see why it becomes that. Right? I don't know. But again, if you like this method, do it. Just make sure you... Okay. So,
I had this in my notes, but I swear I didn't do it yesterday or anything.
Yeah, right. All right.
I swear.
No, it's not.
I just don't want to get half credit on it.
Let me see. Who needs that section 10.3 handout?
When you gave it yesterday?
Wait, no, I don't need it.
So don't do it this year?
Yes. Anybody else need that? So let's do that. Let's group up. Group up. Group up. Let's do it. Get into groups. Or don't. I can't really force you. And just go ahead and try to do these problems. We'll do these together when you're done.